Ladies and gentlemen, imagine a world where the trucks that move everything you use are no longer loud, dirty, or unpredictable, but silent, powerful, and smarter than ever before. Imagine a machine that doesn't just carry cargo but reshapes global trade, cuts costs, cleans the air, and makes our roads safer at the same time. What if the biggest transformation in transportation wasn't happening in cars but in the vehicles that run the world behind the scenes? Today you're about to discover why one bold decision is redefining freight energy and the future of how everything moves. And the real reason this company developed the semi-truck goes far beyond building a bigger vehicle or entering another market. It began with a clear problem. Freight transportation is one of the largest sources of emissions, operating costs, and inefficiency in the global economy. Millions of trucks move goods every day, burning enormous amounts of fuel, producing noise pollution, and wear on infrastructure. Solving this problem at scale offered an opportunity to improve logistics, reduce environmental impact, and redefine what heavy-duty transport could be in a modern energy system. And from the start, the goal was not to create a novelty electric truck, but to build the safest, most efficient, and most economical semi on the road. Traditional diesel trucks are expensive to operate, with fuel costs, maintenance, and downtime eating into margins. By rethinking the drivetrain from the ground up and replacing internal combustion with electric propulsion, the semi-truck was designed to dramatically lower the total cost of ownership. Electricity is more stable and often cheaper than diesel, and electric motors have far fewer moving parts, reducing maintenance and improving reliability over millions of miles. And efficiency was treated as a system-level challenge. Aerodynamics were optimized to reduce drag. The battery pack was engineered to handle long-haul distances, and regenerative braking was designed to recapture energy on descents and during stop-and-go traffic. Every design choice focused on moving more cargo using less energy. This efficiency directly translates into higher profitability for fleet operators, while simultaneously lowering emissions across supply chains. And safety was another core reason behind the semi-truck's development. Heavy trucks are involved in some of the most severe road accidents, often due to long stopping distances, driver fatigue, and mechanical failures. By placing the driver in a central seating position, improving visibility, and integrating advanced driver assistance systems, the semi-truck was built to raise safety standards for commercial transport. Electric braking systems deliver faster response times, while stability control and traction systems help prevent jackknifing and loss of control in challenging conditions. And the semi-truck also plays a strategic role in accelerating the transition to sustainable energy. Freight transport cannot be decarbonized by passenger vehicles alone. Long-haul trucking represents a critical piece of the global emissions puzzle. By proving that electric trucks can match or exceed diesel performance, the semi-truck challenges the assumption that sustainability requires compromise. It demonstrates that clean energy solutions can be faster, more powerful, and more economical at industrial scale. And infrastructure integration was another driving factor. The semi-truck was developed alongside high-capacity charging solutions, designed specifically for commercial use. These systems enable rapid energy replenishment during mandatory driver rest periods, ensuring that long routes remain practical. This approach aligns vehicle design with energy generation and storage, creating a cohesive ecosystem, rather than a standalone product. And beyond technology, the semi-truck reflects a long-term vision for logistics. Autonomous capabilities, fleet-level data optimization, and energy management are all part of a future where goods move with minimal waste and maximum efficiency. Electric trucks can integrate directly with renewable energy sources, on-site storage, and smart grids, turning distribution centers into energy hubs instead of fuel depots. And ultimately, the real reason the semi-truck was developed is impact. Heavy transport shapes economies, cities, and the environment. Transforming this sector has the potential to reduce emissions at scale, lower costs for businesses, and make roads safer for everyone. The semi-truck is not just a vehicle. It is a platform designed to redefine how goods move in a world shifting towards sustainable energy, advanced automation, and long-term efficiency. And this platform thinking extends into how fleets operate on a daily basis, where data becomes as valuable as horsepower once was. Electric drivetrains generate precise real-time information about energy use, performance, and we're allowing operators to optimize route schedules and maintenance with unprecedented accuracy. Instead of reacting to breakdowns, fleets can move toward predictive maintenance, reducing downtime and increasing vehicle lifespan. This shift turns transportation from a reactive business into a continuously improving system. And another key motivation behind the semi-truck was driver experience. Long-haul trucking is demanding physically and mentally, and driver shortages are a growing challenge worldwide. The interior was designed to reduce fatigue, improve comfort, and give drivers a greater sense of control. Smooth acceleration, reduced noise, and simplified controls change how long hours on the road feel. By making the job safer and more comfortable, the semi-truck supports retention and attracts a new generation of drivers who expect modern technology in their workplace. And performance was also central to the decision to build this vehicle. Heavy trucks must deliver consistent torque under load, climb steep grades without slowing traffic, and maintain speed efficiently over long distances. Electric motors excel in these conditions, providing instant torque and precise control regardless of load. This capability improves traffic flow, reduces congestion on inclines, and shortens delivery times. Faster, more predictable transit has ripple effects throughout supply chains, improving inventory management and reducing waste. And the semi-truck was developed with scalability in mind. It is not limited to a single use case or region. Whether operating on short regional routes or long-haul corridors, the architecture is designed to adapt. Battery technology continues to advance, energy density improves, and charging infrastructure expands, allowing performance to increase over time without redesigning the entire vehicle. This future-proofing ensures that early adopters are not locked into obsolete technology as the energy ecosystem evolves. And there is also a broader economic rationale. Fuel price volatility creates uncertainty for businesses and raises costs for consumers. Electrifying freight transport introduces greater predictability, especially when paired with renewable energy and on-site storage. Companies can generate their own power, store it, and use it directly for transportation, reducing exposure to external shocks. This level of control strengthens resilience across industries that depend on reliable logistics. And the environmental impact reaches beyond tailpipe emissions. Electric trucks reduce noise pollution in urban and suburban areas, making nighttime deliveries more feasible and reducing congestion during peak hours. Cleaner air improves public health outcomes, particularly in communities located near highways, ports, and distribution centers. By addressing these external costs, the semi-truck contributes to a more balanced relationship between commerce and society. And the development of this vehicle also sends a signal to the broader market. Innovation in heavy transport had remained largely incremental for decades, constrained by assumptions about what was possible. By introducing a fundamentally different approach, the semi-truck challenges competitors, suppliers, and regulators to rethink standards and expectations. This competitive pressure accelerates innovation across the industry, amplifying the original impact far beyond a single product. And integration with automation is another critical factor. Advanced driver assistance features improve safety today, while laying the groundwork for higher levels of autonomy in the future. In freight transport, autonomy has the potential to increase utilization, reduce human error, and lower costs further. The semi-truck was designed with this trajectory in mind, ensuring that hardware, software, and sensors can evolve together as regulations and technology mature. And at its core, the decision to develop the semi-truck reflects a belief that the hardest problems are often the most important ones to solve. Passenger vehicles alone cannot transform the energy landscape. Industrial systems, logistics networks, and heavy transport must also change. By focusing on one of the most challenging segments of transportation, the semi-truck represents a commitment to tackling impact at scale, applying first principles thinking, and proving that efficiency, performance, and sustainability can advance together within a single unified system. And this commitment to solving problems at scale naturally influences how manufacturing itself is approached. Building a heavy-duty electric truck requires rethinking production methods, materials, and supply chains. Components must be designed for durability over millions of miles, while remaining efficient to produce in volume. By simplifying mechanical systems and relying more heavily on software-driven optimization, the semi-truck reflects a manufacturing philosophy focused on long-term reliability and continuous improvement rather than short-term gains. And energy storage plays a central role in this approach. The battery system is engineered not only for range, but for longevity under demanding conditions such as high loads, frequent fast charging, and extreme temperatures. Thermal management, cell chemistry, and pack architecture work together to ensure consistent performance throughout the vehicle's lifespan. This durability reduces replacement cycles and supports a lower environmental footprint over time, reinforcing the idea that sustainability must be measured across the full life of a product. And the semi-truck also reshapes how fleets think about energy management. Instead of relying solely on external fuel suppliers, operators can integrate charging with their own energy assets. Solar generation, on-site storage, and intelligent load balancing allow charging to occur when energy is cheapest and cleanest. This transforms depots into strategic energy centers where transportation power and data intersect. Such integration increases efficiency across operations and reduces strain on public infrastructure during peak demand periods. And another important dimension is global applicability. Freight transport challenges vary by region, but the underlying inefficiencies are universal. Congested highways, rising fuel costs, and tightening emissions regulations affect markets worldwide. By developing a platform that can be adapted to different regulatory environments and logistical needs, the semi-truck is positioned as a global solution rather than a regional experiment. This adaptability ensures that improvements in one market can inform progress in others, accelerating overall adoption. And the vehicle also influences how companies measure success. Traditional metrics focused on upfront purchase price fail to capture the full picture. Total cost of ownership, uptime, energy efficiency, and safety outcomes become more meaningful indicators. By excelling in these areas, the semi-truck encourages a shift toward long-term value creation. This mindset aligns financial performance with environmental responsibility, reducing the perceived trade-off between profit and sustainability. And human factors remain central throughout this transformation. Training, support, and intuitive design are essential for adoption at scale. The semi-truck leverages familiar digital interfaces, over-the-air updates, and remote diagnostics to simplify operations for drivers and fleet managers alike. Updates can improve performance, efficiency, and safety without taking vehicles out of service, turning the truck into a continuously evolving asset rather than a static piece of equipment. And there is also a broader systems impact on how goods move through cities and regions. More efficient and predictable trucking enables tighter coordination between manufacturing, warehousing, and retail. Reduced delays and improved reliability allow businesses to carry less inventory while maintaining service levels. This efficiency cascades through the economy, lowering costs, reducing waste, and improving responsiveness to demand. And the semi-truck's development underscores the importance of challenging entrenched assumptions. For decades, heavy transport was viewed as incompatible with electrification due to range, weight, and power requirements. By addressing these constraints directly through engineering and system design, the semi-truck demonstrates that limitations are often the result of legacy thinking rather than physical reality. This shift in perspective opens the door to innovation across other industrial sectors. And as adoption grows, network effects begin to emerge. More electric trucks justify expanded charging infrastructure, which in turn lowers barriers for additional fleets. Data collected across vehicles informs better software routing and energy management strategies. Each deployment strengthens the ecosystem, creating momentum that accelerates the transition away from fossil fuels in freight transport. And ultimately, the ongoing expansion of this platform reflects a long-term view of progress. Transforming heavy-duty transport is not a single milestone, but a continuous process of refinement, learning, and scaling. By aligning vehicle design, energy systems, manufacturing, and software into a cohesive whole, the semi-truck serves as a practical demonstration of how complex, high-impact industries can evolve toward a cleaner, safer, and more efficient future, while meeting the real-world demands of global commerce. And this evolution also reshapes the relationship between technology providers and fleet operators, moving it closer to a partnership than a simple transaction. Continuous feedback from real-world usage informs software updates, efficiency improvements, and design refinements. Vehicles in operation become sources of insight, revealing patterns in energy consumption, driver behavior, route efficiency, and component wear. This feedback loop enables faster iteration and ensures that improvements are grounded in actual operational needs rather than theoretical assumptions. And the semi-truck further redefines resilience in transportation networks. Electric systems are inherently more adaptable in emergency scenarios, especially when paired with distributed energy resources. Fleets with on-site generation and storage can continue operating during fuel shortages or supply disruptions. This resilience is increasingly important as climate-related events and geopolitical uncertainties place stress on traditional energy systems. By decentralizing energy dependency, freight operations gain a level of independence that strengthens entire supply chains. And there is also an educational effect that accompanies this shift. As electric heavy transport becomes more visible on highways and at logistics hubs, it changes public perception of what sustainable technology looks like. Clean energy solutions are no longer confined to small vehicles or niche applications. They are large, powerful, and industrial. This visibility builds confidence among businesses, policymakers, and the public, accelerating acceptance and encouraging supportive infrastructure and regulatory frameworks. And the semi-truck influences how regulations themselves evolve. Safety standards, emissions rules, and efficiency benchmarks were largely written around internal combustion technology. Introducing a fundamentally different platform invites regulators to rethink how performance and safety are measured. This can lead to smarter outcome-based regulations that reward efficiency and safety, rather than prescribing specific technologies. Over time, this regulatory alignment supports faster innovation and broader adoption across the industry. And economic ripple effects extend into manufacturing and employment. Building electric trucks at scale creates demand for new skills in software, power electronics, and energy systems. At the same time, simplified mechanical architectures reduce complexity and increase production efficiency. This shift supports a more flexible manufacturing workforce and enables faster scaling without sacrificing quality. As production grows, economies of scale further reduce costs, making electric freight increasingly accessible. And the semi-truck also interacts with urban planning and infrastructure development. Quieter operation and zero tailpipe emissions make it easier to integrate freight movement into dense areas without compromising quality of life. Cities can rethink delivery windows, reduce congestion, and improve air quality simultaneously. This opens the door to more efficient urban logistics models where goods move smoothly without conflicting with residential needs. And from a systems perspective, electrified freight aligns closely with digital logistics platforms. Route optimization, load balancing, and real-time tracking become more effective when paired with predictable energy usage and performance characteristics. Software can account for terrain, traffic, and weather to maximize efficiency, while energy consumption becomes another variable to optimize rather than an uncontrollable cost. This integration strengthens decision-making across logistics operations. And the semi-truck's design philosophy also emphasizes longevity and upgradability. Hardware and software are built to evolve together, allowing performance improvements through updates rather than replacement. This approach reduces waste and ensures that vehicles remain competitive over longer service lives. Instead of depreciating rapidly, the truck becomes a durable asset that improves with time, aligning incentives for both manufacturers and operators. And as more fleets transition, collaboration between companies increases. Shared charging infrastructure, standardized components, and interoperable software systems reduce friction and accelerate deployment. Competition remains strong, but it is complemented by cooperation around common challenges, such as grid integration and infrastructure expansion. This balance helps the entire sector move forward more efficiently than isolated efforts ever could. And the broader energy ecosystem benefits as well. Large-scale charging creates predictable demand that supports investment in renewable generation and storage. Freight fleets can act as flexible energy consumers, charging when supply is abundant and reducing load during peak periods. This flexibility helps stabilize grids and makes higher penetration of renewables possible without compromising reliability. And at a cultural level, the semi-truck represents a shift in how progress is defined within heavy industry. Performance is no longer measured solely by raw power or speed, but by efficiency, intelligence, and integration. Success becomes multidimensional, combining economic strength with environmental responsibility and social impact. This redefinition influences how future technologies are evaluated and adopted. And the ongoing refinement of this platform reflects an understanding that transformation happens through persistence and iteration. Each mile driven provides data, each update improves performance, and each deployment strengthens confidence. The semi-truck continues to evolve within a larger movement towards smarter, cleaner, and more resilient transportation systems, reinforcing the idea that meaningful change in global logistics is achieved not through isolated breakthroughs, but through sustained system-wide innovation applied consistently across time and scale.